Now we are going to talk about a Git command called bisect. Before we talk about bisect, first we need to talk about searching. In this example, we have an array of names and we want to find Gary. The naive way to do it is to simply go through and pull each element off the array. We then compare that to Gary and stop when we find Gary. As you can see, if Gary is the last name in the list, we would have to check every item. That doesn't scale very well as our list gets larger and larger. One solution to this problem is called a binary search. It has one requirement, and that is that our list must be sorted. In this case, our list is in alphabetical order. We pick halfway, in this case Frank, and we check that and we see that it is not Gary. Next, we decide, does Gary come before or after Frank? It comes after Frank. So we drop everything before Frank from our search area, and we've just cut it in half. Then we repeat until we find Gary. Every iteration, our search area gets cut in half. What does searching have to do with Git? A lot, actually. Often we may have a feature that we know works in our most recent release, but somehow, as we're developing the next version, we have broken it. Sometimes we might not notice it right away, so we might have a lot of commits to sort through. So we have a known good commit, our last release, and we have a known bad commit, the current one that has the bug. We need to find the commit that introduced that bug. Up until that commit, all was good, and at that commit, the bug first started showing up. Finding that commit gives us a lot of information. We can see exactly what changed in that commit, and we can use that to help us locate and fix the bug. Even better, if the commit is small and targeted, maybe we can just revert that one commit and our bug will go away. So how do we find the commit that introduced the bug? Well, the naive way is to check out every commit one at a time and check for the bug. In a large repository, that could take a while. Luckily for us, Git has a built-in command called bisect that performs a binary search. You are going to get practice with this in an exercise, but here are the basics. You start Git bisect and you provide it with the known good commit and the known bad commit. And the bad commit is usually head, that's where you're at now. Then Git breaks the search in half and checks out that commit that is halfway. Then you tell Git if that commit that is checked out is good or bad, and based on that it throws out half the search area. Then it repeats until it finds the commit that introduced the bug. Git then spits out the commit where the bug first appears. There are two ways to use Git bisect. It can be difficult to write an automated test for a variety of reasons, so Git gives you the ability to run a manual test. Git stops on a commit and waits for you to manually run the test and tell it the result. Then based on what you tell it, Git throws out half the search area and picks another commit, and then repeats. The other way to use bisect is automatically with a script. So when you find a bug, one of the first things you should get in the habit of doing is writing a unit test to detect it. That has a couple advantages. One, you can add the test to your unit testing suite, so if you happen to reintroduce that bug, you will know immediately. The second advantage is that you can use that test with Git bisect. You can use the Git bisect run command to provide Git bisect with a script that outputs 0 for good and 1 for bad. At each checkout, Git runs the script automatically and uses its output to determine what to do next. Luckily for us, we can use the LabVIEW CLI tool to call LabVIEW VI programmatically and specify a return value. One thing to be careful with is that you should make sure that your test has not been committed into the repository. Bisect is going to be messing with your working directory, so you want to be careful. You probably want that test to stay the same for each checkout.